IP security, Internet Protocol Security. In this, have a range of application specific security mechanisms. Example, if you are going with respect to SMIME, that is mail extensions, and PGP, method of protocol, Kerberos, and SSL and HTTPS. These are the different type of security mechanisms which are used whenever the with respect to the applications. If you are going with respect to applications, different type of security mechanisms are there. With respect to that, we'll be transmitting the or we are using the security methods. However, there are security concerns that cut across protocol layers. With respect to security concerns, whatever the security methods, security formats or protocols we are using, they will be having the concerns with respect to the protocol layers in with respect to what level it will be providing the security. Okay, if we are going for TLS transport layer, at the time of transportation only you will be having the security. In that way, you will be having the concerns or restrictions related to the transmission of data and restriction related to the security provided with respect to the layer. Okay, that is also one part. And would like security implemented by the network for all the applications. It will be like security implemented by the network for all the applications. And the general IP security mechanisms are, it provides authentication, confidentiality, and key management. Whenever we are going with respect to IP security, always it will be providing authentication, confidentiality, and key management procedures with respect to transmission of data through internet. Applicable to use over LANs across public and private WANs, wireless area networks, and for the internet. All the three methods can use IP security. LAN means within one area you are connected through lines, and each and every systems are provided with the security with the IP security also. And across the public and private VPNs. VPNs, wireless area networks, means in if we are considering with respect to any software industries or any IT firms and all, the systems which are connected inside one industry or one department are connected with the private wireless network. Means each and every systems can access the whole server of the industry, and also they can access the persons access the applications of one person who has completed first part, that can be accessed by the another person. In that way, private and public wireless area networks are created. And also with respect to the internet means if one system is connected with another system through the internet, how we can provide the security using IP security. That is related to three application applicable with respect to the use over LANs, WANs, and internet, that you should remember. And need identified in 1994 reports need of authentication, encryption in IPv4 and IPv6. In both representation, we can get the encryption with respect to version 4 and version 6. You can see IP security users. If I am showing with respect to user system with the IP security, if we are providing whatever the data we want to transmit, that will be a payload. Okay, secure IP payload will be having, and IP security header will be added, and IP header will be added with respect to the data transmission to the public or private network of internet. If I am connected with the internet, then if I am transmitting the data from my user system towards the other systems, then you will be transmitting the data in this format. First payload will be there with the IP security. IP security header will be added with the payload, and IP header will be there. Then this whole block or whole this block will be sent through the public internet. That will be given to the networking device with the IP security. Here IP header security IP payload will be same whatever the data we have transmitted from the system towards the internet. Internet will also pass on that information towards the networking device with the IP security. It may be for 2 or 3 or which are the routers which are connected with the internet, they will get that information. And then after that, networking device with IP security will take that information. It will take only IP header and IP payload, and the security part will be removed, and then it will be given to the Ethernet switch. Ethernet switch will be providing that information to the actual users who is accessing for that information. That's why Ethernet switch will give that information to the any one of the system who are accessing for that information. Okay, here also IP header same, no, network device with the IP security, IP header with the IP payload with Ethernet switch, server and systems. Server can also store that information and system can access that information. These are the two type of connections of systems and servers that you can see. This I can take it as a WAN, that is where systems are connected with the server through the wireless connection. That also we can take. Here you can take it as a LAN. Okay, LAN connection through wire you are connected with the Ethernet switch from one system to the another system. Okay, LAN, WAN, and you will be having the connection through internet. All those things you can use or check with respect to IP security uses. Okay. Benefits of IP security is in a firewall or router provides strong security to all traffic crossing the perimeter. Traffic crossing the perimeter. Whatever the security lines are there, whenever you are transmitting the data through firewall from your system towards the any website or any other system, then you are providing the security by using IP security through firewall and router. Okay, in firewall or router is resistant to the bypass. It is the router and firewall restrictions or settings are always resistant with respect to the bypassing. No one can bypass towards your system, or you can't bypass to the other systems. Okay, is below transport layer. It is a below transport layer, hence transparent to applications. See, always we have seen with the applications, or we have seen with the transmission of information in such a way that always your IP security is the lowest layer. After that, you will be providing the transport layer security. After that, you will be providing the SSL layer security. And after that, you will be having the headers. In this way, you have provided the security for the information. But if you are seeing with respect to IP security, you will be transmitting the information. Always it is in a lower level. For that reason, it will be transparent with respect to the all the application. Can be transparent to the end user also. Can provide security for the individual users also. See, as we can see, each and every systems are having the IP security. IP address will be provided. By using that IP address only, you can provide the security to your system. That's why if your IP number or your user systems are there, no? If your IP number will be different for each and every system. If that IP number is hacked by any of the person, then whatever the data present in your system can be accessed by the hackers or any third party. Okay, that is the main thing. Can provide the security for individual user also, and secures the routing architecture Z also. It will secure the routing architecture Z. Security architecture. Specification is quite complex with groups. Whenever we are with checking related to IP security architecture. Here architecture RFC 4301, that is an security architecture for internet protocol. If you are going with respect to internet protocol, it provides RFC 4301, which will be giving the architecture with respect to the internet protocol. If you are going for authentication header, with respect to that, different architecture will be there. That's why RFC 4302 IP authentication header will be provided here. And encapsulating security payload, that is EPS, RFC 4303 IP encapsulating security payload will be providing the information. And if you are going for internet key exchange, IKE, and that is of RFC 4306 format, internet key exchange will be provided. Here you can give the information related to versions also, IKE V2, V1 protocol. And cryptographic algorithms can be added with respect to this, and other informations will be provided in the architecture of IP security. And IP services are what all services it can provide to the any of the information which is present in your system, and how we are going to transmit to the other systems. That is provided in the IP security services. One is access control, which all systems can access your server or your system. That is an access control. And connectionless integrity. If without any connections, you can give the integrity towards your system. Data origin authentication. Whatever the data origin in your system, means whatever the new data you are creating, new information you are creating, new program you are writing, or new code you are writing, the origin of authentication will be provided using the IP security only. Okay. Rejection of replayed packets. Yeah, form of partial sequence integrity. Whenever replayed packets are coming towards your system with any of the wrong information, or any of the hacking information, or all those things, if it is coming, you can reject it easily by seeing the IP security layer information. Confidentiality, by providing the encryption, you can create the or provide the confidentiality for your information. And limited traffic flow confidentiality. Whenever you are giving the connection with or settings with respect to the firewall and IP security considerations, at that time you can provide the limited traffic flow with respect to confidentiality. To maintain the confidentiality of the system or data, you can go with the limited flow confidentiality. Next we have transport and tunnel modes. In this too, you can see two differences. One is in transport mode, to encrypt and optionally authenticate IP data, you are going with the transport mode. Can do traffic analysis, but is efficient. And you can do with respect to traffic analysis, but is efficient with respect to the analysis of that. And good with the ESP host and host traffic. Encapsulating security payload, ESP host to host traffic, you are going with transport mode. If you are going for tunnel mode, encrypts entire IP packet. Whatever the IP packet is we have created, that is with the IP header and IP security header and the IP payload, all those things will be present in one packet. If you are encrypting the whole packet, then you are transmitting that information in the form of tunnel mode. Add new header for the next hop, means whatever the next information we are taking, with respect to that, new header will be created and added. No routers on way can examine inner IP header. If any other router is present in between the transmission of tunnel mode, the router can't examine or check the what type of IP header is present in that information in tunnel mode. Good for VPNs, gateway to gateway security. If you are going with respect to gateway security, then you are going with tunnel mode. You can see the transport and tunnel mode in two different diagrams. One is having transport level security here. One device is connected with the internal network, and this internal network is connected to the external network, and then it is connected to the any other system. How we can do this one? See, if I am taking a one example of the any industries, industrial person is working inside the company, he will be working with internal network. Okay, he will be connected with the internal network, and he will be working in the industry only. And if the person is doing work from home, if that one, if I am taking as an example, the data which is present in the industrial systems can be transmitted through the internet network using the encrypted TCP sessions. After that, it will be connected to the external network, and from the external network, the person who is present in some other place can access the data which is present in this industrial systems. Okay, that is transport level security. This you can understand, I think. Okay. Next, if you are going for tunnel mode, a virtual private network via tunnel mode can be created. Here, as I told you as an example with respect to corporate networks, here also same corporate networks are there. 4 different corporate networks are there. If you want to transmit the information from one to another one, you can't transmit simply through the internet towards the other system. Always you will be having the tunnels with respect to one network to the another network. See, from this, if I am taking it as A and B, A to B, you can use only single tunnel which is connected from A to B. Okay, and if you want to do it with respect to B to C, one more tunnel will be there, and C to D, one more tunnel, D to B, one more tunnel, and A to C is one more tunnel. Always the transmission from one system or one network to the another network will be done through the IP, sorry, tunnel mode. If you are using the tunnel mode, then in intermediate any of the router comes in this tunnels, then they can't access the IP header information or IP security header information. That is the main security which is provided in your tunnel mode transmission method. In this, you can see the transport and tunnel mode protocols, how we are going to add the information, add the header, all those things we can see. Tunnel mode and transport mode. If you are seeing with respect to transport mode, in IP security level, data will be there and TCP header will be there, ESP header will be added, origin IP header will be added, and you will be having ESP authentication, and you will be having ESP transmitter and receiver information. This is the actual IP security header. Always with respect to, if you are seeing with respect to from where you are going to add all those headers, first application data, the data will be there. After that, if you are going for TCP layer transportation security, data will be added with the TCP header. This TCP header, after adding the TCP header, it will go to the IP layer where data TCP header. After that, you will be adding the origin of IP header security header. After that, IP security will provide with respect to ESP header whenever you are going with the transport mode. And with respect to that, authentication and transmitter and receiver information, everything will be present in your this layer, IP security protection layer. If you are going for tunnel mode, what you can see, application will be there, and TCP in TCP layer, TCP header will be added, and in IP layer, origin IP header will be added. In IP security layer, same as your IP security, here ESP header and ESP transmitter transportation layer and authentication all will be added, but only difference is here in transport layer, ESP header is added in between the origin of IP header and TCP header, but in this tunnel mode, ESP header is added above your origin IP header. Okay. And if you one more layer of IP security will be provided in tunnel mode, because whatever the origin IP header is there, that should not be read by any of the person in between the router information or any intermediate internet network. Okay, that's why you will be providing one more new IP header. Wherever other routers will come, they will take only this new IP header. They can't see check this origin IP header. In this way, you can provide the security towards your data, which is transmitted from one network to the another network through the tunnel mode. Okay, this is the actual difference between transport and tunnel mode. Whenever they are asking related to this transport and tunnel mode, you have to explain it properly with transport and tunnel mode, and then you have to draw these two diagrams with respect to transport level and tunnel mode transportation, and also you have to write the protocol how these headers will be added to your data and transmitted. Okay. Next, we have security associations. With respect to security associations, a one-way relationship between sender and receiver that affords security for traffic flow. Whenever the data transmission from one person to another person, that is receiver to the transmitter or sender to the receiver, whenever you are giving that information, the one-way relationship between the sender and receiver will be, and what all type of security it has to be needed, and with respect to the data transmission, and defined by the three parameters, that is security parameters index and IP destination address, security protocol identifier. These three are the parameters which will be present in your security associations. What they have to check here. Security parameter index means what all the type of security they are providing. Is it TCP protocol and they are using SSL protocol? Is they are using a handshake protocol? Is they are using IP security method? Is they are using PGP method? All the and what type of encryption they are using? What type of compression method they are using? All those things they can see in the this security parameter index. IP destination address. With respect to destination, whenever your sender is sending the information, if they don't know to whom they are sending, then what is the use? They can't send the data towards the destination. For that reason, whenever their sender is sending the information towards the receiver, the destination IP address should be known to the sender. And security protocol identifier. What all the type of security protocols we are using, and at the destination address you should know what all the security protocols the transmitter are using or sender is using. Okay, if they know related to the what type of security protocols they are using, then only they can decrypt it and get the information. Now, for that reason, security protocol identifier is needed at the destination. Has a number of other parameters are sequence number, EH info, lifetime, etc. All those things are present, and have a database of security associations. What all the different type of security associations are there and how it will be used. If you know have the database, then easily you can compare with respect to what type of security methods are used or security parameters are used. All those things you can check in the database only. That is related to security association. Security policy database, where it relates IP traffic to specific SS security associations, match subset of IP traffic to relevant security association, and use selectors to filter outgoing traffic to the map, and based on the local and remote IP addresses, next layer protocol name or local remote ports can be verified. Here you have here they have given some of the example of the IP addresses. See, if you are going for UDP, user level protocol, that is local IP address, whatever the address will be, local IP address, ports will be 500, Remote IP you don't have, port is 500. Action is bypass, IK, comment is IK. If I am going for ICMP, one same IP numbers are there, ports you won't be having. Action, error message. If you don't get this port information or not, error message will be there without any protocol. But a remote IP is present. Protect ESP transport mode. Encrypt intranet traffic, which represents that here you don't use any protocol, but local IP address is there, remote IP address is there. Means this is of industrial IP address, where you are connecting and transmitting the information towards the remote IP. Means we are using the ESP intranet, in transport mode, and encrypt the intranet traffic. Whatever the data we are transmitting from this data towards this IP address towards a remote IP address, you have to encrypt the data before transmitting it. If we are using TCP transport protocol from the industrial intranet towards the internet, port address is also given. ESP intranet in transport mode is used. Encrypt to the server. That is with respect to server address they are given. TCP method is used. Port is used. Bypass method is used. TLS, avoid the double encryption whenever we are going with respect to the remote and transport ports. Discard other in DMZ. If the action is discard, some other people is accessing the intranet or industrial information, that is with respect to whatever the secured information which is present in the industry, that should not be given to some other person. For that reason, you have to discard that connection. If you are going for only local IP bypass, it can be directly connected to the internet. Okay, that is related to security policy database table.